Hello there, my name is Nicholas, and this is our first set of tutorial on how to simulate the ESP32 online with Wokwi. And yeah, we are not using the expressive IDF here, we are using the Arduino framework. So without further delay, let's get started. The very first thing that you have to do is to go onto Google and then write Wokwi simulator. So if you write Wokwi simulator, then if you write Wokwi online, you have the Wokwi ESP32, which is the one that we'll be using. But for you to get started, you first need to have an account. So to sign up, you go on to Wokwi online ESP32 STM32 Arduino simulator. So if you click on this, you have these boards. So with Wokwi, you can simulate an Arduino Uno, an ESP32, different version of ESP32. You have the room, the C3 here, you have the S2 and S3 all. So also I think two board of STM32 and the Pico also board with MicroPython. And you can also simulate it with VS Code that we'll be doing in some other videos. But in this video, and also you have some samples of code here and simulation that you can start with. So the very first thing that you have to do is to get on top here and then sign up, get an account. And then if you have an account, then you have some projects. So you have all your projects here. And you can read all your projects. Yeah, so these are some of my projects. So for the very first thing that you have to do is to create a project. For you to create a project, you need to choose the board that you'll be using during the simulation. And I'll be using the ESP32. And in this short tutorial, we'll be first blinking the built-in LED. So the ESP32 board has two LEDs, one for the user and the other one for the boot, for booting the system. So we'll be blinking the board or the built-in LED using the Arduino framework. So if it is your first time to use the Wokwi, the very first thing that you have to notice is that it has two windows. You have the coding side and you have the GUI side, or the graphical user interface side. And in the coding side, you have three tables here. You have one which is the sketch, and if you are used to Arduino, you know what is the sketch.ino. And you have the diagram.json is the interpretation of the GUI side. So whatever component you add into this GUI side will be also interpreted as a code using the diagram.json file. And the third one is the library. So let's say, for example, we are using an LCD, or we are using whatever component, a servo motor. For example, we need a library which is a set of code written by other people, a group of persons or people that have written the code, and you can just use directly by just clicking here and then looking for the name of the component in the library. So if I write, for example, servo, so I'll have multiple servo libraries that I can include. So all the library will be included here. So in this first tutorial, we will not need to include a library, and we just need three components: the board itself, an external LED, and a resistor. But for the very first time, what we want to do is to blink the built-in LED, which is the onboard LED. So if you open a sketch in Wokwi, this is how it gets. So it first includes these two functions: void setup and void loop. So the void setup is the code or the function that runs once during the running of the code, and the void loop is the section or the function that is keep on running all the time until the board is powered, or until power is removed from the board. Yeah, so if, for example, I click here run, what you will see is just this will run and delay 10 seconds, and you will see it on my side. Let me try to bring this one a little bit so you can see. Move this one. So it's written hello ESP32. So this is the serial print that you have it here. It's what is printing here. So let's say, for example, I write hello learners. So, and then run it. It's compiling. Cool. So what we'll be doing here is, as I said, for the very first time, is to blink the built-in LED. So if you are not familiar with Arduino code, it starts first with defining some input and output port of the board that you'll be using, and then after defining them, maybe a constant that you'll be using during the code, and later some functions that will be called in a loop, for example, or in the setup function, and finally you run it. So we'll first start by defining the pin that we'll be using, and in this case, as I said, since nothing is connected to this board, what I will first do is just call one of the most important function, which is called pin mode. So this function has will use two arguments. So the very first one is the pin that we want to use, and the mode. The mode can be an input, it can be an output, it can be an input pull out, pull up, or an output fall down, or whatever. So for the very first time, what we'll do is to make the built-in LED, which is here, link. So I'll call the name of this LED is called LED built-in. So write LED built-in, and then I want to make it as an output because this is what we want to see. It is not an input. An input is a port that receives real-life data from outside of the board, and the output is whatever is being completed inside the board and being outputted to the user for them to see. So after the pin mode, what we can now do is to use those pins that we've just defined, or the pin that we just defined. And what we do, we can first use one of the function, which is a digital write. And with this digital write, we can write some states to the pin that we just defined here. Okay, so we've defined the LED to be an output, and we want this output to have voltage for some time and remove voltage for some time. So it has voltage, then the LED over there will turn on and we'll see the light, and if it doesn't have voltage, then the LED will turn off. So we want to turn on and off this LED built-in. So the function that can do that is this digital write. So, and this digital write will have two arguments. The very first one is the pin that we want to use, which is this LED built-in. So you can copy paste, or you just write LED built-in. And then what we want is to make it high. If it is high, it means it has voltage, and if it is low, it means it doesn't have voltage. So when you make it high, you want it to be high for a certain period of time. So what I will do, I will delay for, let's say, 5 seconds, and then I'll remove power from it. So for you to remove power, you use a digital write, and then make it low. So, and also another delay. When it's low, you want it to be low for how long? Let's say 500 milliseconds. So let's run it and see. It's built. Then we can observe here that our LED built-in, or the onboard LED, is blinking every 500 milliseconds. So, yep, that is how you can blink the built-in LED of an ESP32 using the Arduino framework. One other thing that we can do is, for example, to make this one 1 second and this one half a second, which is 500 milliseconds. So let's see. Oh, sorry. So it's 1 second, which is 1000 milliseconds. Yeah. So it's building. After the code is being built, which will take some few minutes because of the internet, and then you can see that it will start blinking. Yeah, and also our hello learners is being printed in the serial monitor. Awesome. So here is how we can build how we can blink the built-in LED of an ESP32. So now we can also blink an external real-life LED by just bringing an LED in, and since this is a diode, we need a kind of protection on the LED side. So I'm bringing an LED, and you can change the color. You can choose red, whatever, of this LED. And this is a resistor, so here's the value and here's the unit. So I'm using, for example, 1 kilo ohm resistor to prevent burning this LED. And for you to rotate this, you just use an R. So R will rotate. And also, if you are not familiar with electronic components, most of the time these use DC. So with DC, you have a positive and then a negative. Same for this diode or this LED. So you can see this is the cathode. The cathode of an LED is the negative side, and the anode is the positive side. And the negative of this LED should go to the GND, or the negative of this board. And the positive of this should go through the pin that you want to control. Let's say we want to connect this to pin, let me see which pin we have close. Let's say pin 13. So I'll do, and also this pin 13 is directly connected to the built-in LED. So this LED built-in is directly connected to pin 13. So if for example I run this code, yeah, so this this built-in LED is connected to pin 2, I think so. Yes, so let me connect this to pin 2 and see if I'm correct. Yep, and see. Yeah, I'm correct. So this built-in LED or LED built-in or onboard LED is directly connected to pin number 2. So by saying LED built-in output, I am making pin D2 as an output. So now let's say that I want to connect this to pin 13, which is the same as the Uno board. So what I will do, I'll first define that pin by using define, and then the name is, let's say, LED, and the value will be LED, and the value will be 13, okay, which means pin 13. So then I'll connect this to pin 13, just like this. And I also have to define this pin. So in the pin mode function, I'll make this 13 or LED pin, the LED I just defined, as an output. Also, now what I will do, okay, while the LED built-in is high, I will make this outside or connected LED, this LED, I'll make it low. So I'll write digital, write LED, delay for a second, and then while the other one is low, while the built-in LED is low, I'll make the connected LED high. So let's build and run it and see. Yep, so while the built-in LED is on, the connected LED is off, and when this LED is on, the other one is off. Alright, so let's change this to, let's say, half a second. It's on half a second, and it's off quarter second, which is 250 millisecond. Let's build and run at the same time with the start simulation button. Alright, so awesome, we've been able to simulate the ESP32 in the Arduino framework with Wokwi. And the very first thing that we did was first to get the board and with this sketch, we first blink the built-in LED and finally attached an LED, external LED to pin 13. We define the pin, then set the mode of the pin as an output, and finally write the code using the digital write to make the pin high or low. And making the pin high means triggering the voltage or giving it the voltage, and making it low means removing the voltage. And if you are not also familiar with electronics, we are using 5 volts on this pin. So what this controller or this microcontroller is doing is giving 5 volts here and then removing 5 volts, giving 5 volts and then removing 5 volts. So alright, that is it. And also with the serial print here, serial print line, we saw how to change this word. It was hello ESP32. We changed it to hello learners. And one thing that we can add to this is whenever the LED is on, we write on, and whenever it is off, we write off. That is, let's say for a screen. So for you to print something on the serial monitor, you have to use serial print. Now you have serial print and then you have serial print line. These two, for example. Serial print line means whenever it will write or print something, the next one will be under a new line. So let's say LED built-in on. Okay, so the built-in LED is on at this time, and we also can write for the attached LED by saying LED off. Sorry, so there is a string, so it has to be LED off. So the same thing, I'll copy this and paste it here. So here we know that the built-in LED is off, and also here we know that the built-in LED is, the attached LED is on. So we can compile this and run. Alright, so finished compiling. So let's see what we have here. So when this one is on, you can see LED on, and when it's off, you can see LED off. And when this one is on, you can also see built-in LED on and built-in LED off. So say both here, one is on, one is off. One is on, one is off. One is off, one is on. One is on, one is off. One is on, one is off, and one is off, one is on. So that is it. Alright, cool. So yeah, today we've learned how first to create an account on Wokwi, and how to set up the sketch for the ESP32, and how to build and run the blink code with ESP32. Thanks, and see you for the next tutorial. Bye.